Hello everyone, welcome to our channel. Let's start with today's topic, that is layer 2 communication in Ethernet network. Before even beginning with layer 2 communication in Ethernet network, there are a couple of sort of rules, thumb rules which you need to know and keep in mind to understand the layer 2 communication in Ethernet. First rule is that final communication between two hosts over Ethernet always happens using MAC addresses. This MAC address is a unique identifier assigned to the NIC card or the network interface of each device. Uh, this is assigned by the manufacturer and is intended to be globally unique to each NIC. Second thing is traffic between two hosts is always switched if it is in the same subnet. Otherwise, it is routed if not in the same subnet. What is same subnet, what is different subnet is also covered in in couple of my shorts related to IP addressing. You can visit that, which are sub 1 minute shorts in our channel. To understand layer 2 communication in an Ethernet network, let's understand how a network frame flows from Sam's PC to Tony's PC in our example. There are three PCs connected to an L2 switch as we see over here. Those are Sam's, Tony's, and David's PCs. All these PCs are in the same subnet. Uh, let's have a look at Sam's PC. Sam's PC basically has an IP address of 10.0.0.1 and a MAC address of AAA. So there is a route table, which is an L3 table, and an ARP table, which is an L2 table. Similarly, Tony's and David's PC will also have its respective um, MAC and IP addresses in their respective route and ARP table. In Sam's PC, when I type this command ping 10.0.0.0.4, what happens over here is this Sam's PC tries to create a frame where it will try to fill the source IP, destination IP, the source MAC, and the destination MAC information. Now, it does not know the destination MAC information of 10.0.0.4. It knows the source IP, which is its own IP. The destination IP is derived uh, from the command which we ping 10.0.0.4. It knows its own source MAC address also over here, correct? Now, here is the most important concept in L2 communication. Since Sam's PC does not know Tony's MAC address, correct? So what happens is this PC generates an ARP broadcast frame with a destination MAC of FFFF. If you see over here, this is the destination MAC of FFFF. This frame is also known as the ARP request frame. Uh, this is a broadcast frame. So what happens is the switch accepts this broadcast frame uh, and multiple copies of this frame is generated by the switch and forwarded to the egress port 2, 3, and so on if any more PCs were there. The other PCs like David PC, uh, Tony's PC, they accept this frame. David PC accepts this frame, it opens it and sees the MAC and the IP address of SAM and it populates it in its own ARP table. So if you see over here, what it does it has its own MAC and IP mapping. It also opened the broadcast frame and it populated the MAC address and the IP address of Tony's Tony's PC. It uh, it also does not reply back to this broadcast frame, since David PC has the intelligence to know that this frame is not intended for him. Similarly, Tony's PC, what it will do is it will also open this frame up. It will open this frame, see the MAC and the IP information of Sam, and also it will see its own IP address information in the destination IP field of this broadcast frame. And Tony's PC, what it is doing is it is populating its ARP table also, and it is generating the ARP reply over here. This ARP reply is generated and sent back to Sam. This ARP reply is sent back to SAM. Now the SAM's PC receives this reply and it updates its own ARP table. So it updates its own ARP table and you see that the IP and MAC address entry of uh, Tony is updated over here. Now SAM's PC has all the entries to send the ping packet frame and the final frame is generated from all these entries. This is how the final frame will look like, where it is populating the source IP, destination IP, source MAC and destination MAC. Hence, this explanation now summarizes the communication of packet in the layer 2 Ethernet network. In this layer 2 communication, there are important switching layer 2 switching points which we need to keep in mind. This is related to the dynamic MAC address table which the switch has. The switch basically has its own dynamic MAC address table. Now what happens is during the communication between the host, the switch uses the incoming frame to learn where the sender is located. So uh, when we see over here, when the frame was moving from triple A, what the switch does is it opens the frame, it sees what is the sender MAC address and populates it accordingly. So when this unicast communications happen or the broadcast communications happen, or when communications happen between all these three PCs, the switch has a sufficient amount of frames where it is doing the lookup, and in the first lookup itself, the switch populates the information that port 1 is connected to AAA, port 2 is connected to triple B, port 3 is connected to triple D. Uh, this is the point dynamic is very important over here. Why this point dynamic is important is the MAC address can change also. So for example, another PC can also connect to one and this PC can be replaced connected to uh, slot 1 and this will also be dynamically updated. Hence what we call it the table is a dynamic MAC address table in the switch. Other two important switching points which we need to keep in mind is, as I mentioned earlier, the ARP request frame, which the sender PC sent, it had the broadcast frame. So what the switch does is, the layer 2 switch basically, it it takes this frame and it generates multiple copies of these frames and forwards it to all other ports. It never generates its own broadcast frame. Second point, if sender and receiver are on the same port, switch blocks the information. If sender and receivers are on different ports, the switch will bridge the information between the appropriate ports and not to all the ports. Thus, what happens is there can be multiple senders, multiple receivers on the switch. This behavior of switch of bridging the information to the appropriate ports and not to all the ports will help in simultaneous communication between pair of hosts connected on different ports. Correct? So this sums up our layer 2 communication on the Ethernet switch. Thank you. Thank you for your time. Please do like, share, subscribe, and stay connected. Also, do share, comment on any suggestions on how did you like the video, what you want us to improve on this. Okay. Thank you, and see you again.